CSE physics, that one is force. So first we are going to define the force. So as I have written here, force is an external agent which change or tends to change the state of motion or rest of a body. Okay, so that one is called force. Now the SI unit of force is, as we know, that it is Newton, and it is represented by capital N. The CGS unit of force is dyne. Okay, it is called dyne. Sometimes in exam they will ask you that what is the relation between dyne and Newton. Okay, so for that relation, first we have to find that what is one dyne. Okay, so dyne is CGS unit. Suppose I have to represent the unit of force, okay, in MKS system, whereas we know that force is equal to mass into acceleration. Okay, so what is the unit of mass? It is kg, and unit of acceleration is meter per second square. So kg meter per second square. Okay, so 1 Newton can be written as 1 kg meter per second square. So this one is called 1 Newton. Now suppose I have to convert this 1 kg meter per second square into gram centimeter per second square. Then what we have to do? First we have to convert this kg into gram. Okay, so converting this kg into gram, how we will convert this kg into gram? By multiplying it with 1000, because we know that 1 kg equal to 1000 gram. And also we have to convert this meter into centimeter, and we all know that 1 meter is equal to 100 centimeter. Okay, so for converting this meter into centimeter, again we have to multiply with 100. Okay, so what we have got here, 1 kg meter per second square will be equal to 10 to the power 5 gram centimeter per second square, and this gram centimeter per second square is called as dyne. Okay, so here I am writing 1 dyne is equal to 1 gram centimeter per second square. So through this equation we can write that 1 kg meter per second square is equal to 10 to the power 5 dyne. Okay, so this relation you have to remember that. Now we have to discuss that whenever force is acting on any object, so which type of motion it is going to generate. So generally whenever force is acting on a body, it will produce two types of motion. First one is linear or translation motion, and second one is rotational motion. Okay, now when force is going to generate this motion, linear or translation motion, now suppose there is one object which is placed on a surface. Now suppose we are applying one force on this object, so this force is acting in this direction. Okay, suppose this force is acting on this body, so what will happen to this body? This body is going to slide. Okay, this body is going to slide over this surface, and there is displacement of this object. So here we have observed that the body has moved in a linear motion. Okay, now suppose instead of placing this object on surface, suppose I keep this object on an structure like this. Okay, now suppose I keep this object instead of this plane surface, I have kept this object in this pivoted plane. So what will happen? This, whenever we apply force in this object, okay, this object trying to rotate, it will try to rotate in this direction. Okay, it will lose the contact in the below surface. Okay, here it will lose the contact and it will try to rotate about this point O. So this type of motion is called rotational motion. Okay, now here also we have seen that we have fixed this circular disc into the center. Okay, this one is called pivoted point. Okay, so whenever we fix this object at its center and we are applying the force in this direction, so what will happen? This body try to rotate in this direction. So have you seen that now when we fix the object, it will try to rotate, and the object, whenever object is free to move, it will try to translate in a linear motion. So force will produce two types of motion. In this chapter we have to study this effect, the turning effect of forces. And in turning effect of forces, first we have to discuss moment. Okay, so what is so moment is the product of force and perpendicular distance from the point of rotation. So first we are going to understand what is point of rotation. Okay, so point of rotation, or sometimes it is called as axis of rotation. Okay, so axis of rotation or point of rotation, it is the point about which any object is rotating or tends to rotate. Suppose this one is fan. Okay, so this fan is fixed in our ceiling. Okay, and this fan is rotating. So suppose I have to find the axis of rotation of this fan. So what we have to do, this line, okay, the line which is passing through the center, this one is called axis of rotation. Now suppose we have fixed one circular disc like this, and we are applying force here. So what will be axis of rotation or point of rotation for this disc? Okay, this point, okay, point A is called axis of rotation for this point. Suppose we hang one bar like this, and this bar is hinged at this point. Okay, hinged means this one is called hinged. Hinged means it is not permanently fixed. Okay, it is capable to rotate like this in this direction. It is going to oscillate. Okay, so this type of fixing is called hinged. Now suppose I apply the force at this point. So what will happen? This bar is going to rotate in this direction, and its axis of rotation is this. Okay, this one is axis of rotation. So this one is called axis of rotation. Now we come to discuss the moment. So moment is force into perpendicular distance from axis of rotation or point of rotation. In short, it can be written as F into D, where D is perpendicular distance. Okay. Now the SI unit of moment is, as we see that from formula, what is the unit of force? It is Newton. And what is the SI unit of distance? It is meter. So it will come what? Newton meter. Okay, so Newton meter is the SI unit of force. And also we know that 1 Newton meter is equal to 1 joule. Okay, so sometimes in option they will give you joule also. Okay, so joule is also the SI unit of, or unit of moment. Okay, so this one is the unit of moment. Now let's understand how to find the moment. Okay, suppose this one is one disk, and this disk is fixed at its center. One force whose magnitude is 5 Newton is acting on this disk. Okay, and this disk has diameter 10 meter. Now suppose I have to find moment of this, moment produced due to this force. Okay, about this center O. Okay, because this one is axis of rotation. So now how we are going to find? As I have told you that moment is equal to force into perpendicular distance. So we have to take the perpendicular distance. So this one is our force. Okay, and this one is our axis of rotation. So axis of rotation and force, the line of action of force, we have to take this perpendicular distance. Okay, so this distance is how much? 5 meter. So force is 5 Newton and distance is 5 meters. So it will come 25 Newton meter. Now instead of fixing this disc on its center, suppose I fix or hint this disc at this point. Okay, and this one is the center of this disc. O is the center of the disc. Now again, there is one force whose magnitude is 2 Newton, which is acting on this disc. So now in this case, suppose I have to find moment. So what we have to do, we don't take the distance from center. Okay, we can't take distance from the center because now this object is rotating about this point. So we have to take this distance. Okay, so this total distance we have to take. This one is the perpendicular distance. And this distance is what? It is the diameter of this disc, 10 meter. Okay, so this one is the force. Force is acting in this direction, and we are taking distance, perpendicular distance. This one is 90 degree. So this one is 10 meter, and this force is 2 Newton. So moment is equal to force into distance. So force is 2 Newton, and distance is 10 meters. So it will come 20 Newton meter. Now let's take another example. Suppose this one is bar. Okay, rod. This rod has total length 10 meter. Okay, and this rod is hinged at this point. This is suppose point O. So this rod is capable to rotate about this point O whenever we apply the force. Now here 3 forces are acting on this rod. First one is 4 Newton, 5 Newton and 6 Newton. Now again we have to find the moment of these all forces. So let's take this force first, 4 Newton force. Okay, so as we have seen that, suppose this one is F1, this one is F2, and let's consider this force as F3. Now let's find the moment due to force F1. So we can write M1 is equal to F1 into T1. F1, how much magnitude of F1? 4 Newton into perpendicular distance. So in this case, what is the perpendicular distance between the axis of rotation or point of rotation and the force? So when we extend this force, as you have noticed that this force is going to passes through the point of rotation. Okay, so there is no perpendicular distance between this force and the point of rotation. So in this case, this distance is 0. So moment will come how much? 0. Okay, so always we have to check that whether the force is passing through point of axis or point of rotation. Okay, now let's take moment due to force F2. So M2 is equal to F2 into D2. F2 is 5 Newton and distance is what? This force is acting at the center. So this distance will be 5 meter. So 5 meter. So it will come 25 Newton meter. Now let's find M3 for moment due to force 3. So F3 into again D3. F3 is 6 Newton and again we have to find perpendicular distance. So again extend this force in this direction. Okay, so you have noticed that this force is also going to pass through the axis of rotation. So there is no perpendicular distance or offset distance between the force and axis of rotation. So in this case also distance is 0. So moment will come what? 0. So through this example, we have understood that how to find the moment. Okay, now what are the factors which affect the moment? Okay, so we know that moment is equal to force into perpendicular distance. So through this formula, we notice that the moment is depends on two quantity, force and perpendicular distance. So it will depend on magnitude of force F. How it is going to relate with F? If F is 0, then moment is also going to 0. Okay. Second one is the factor on which moment depends is perpendicular distance from axis of rotation. That one is D. Okay. Here also if D is 0, then moment is also going to 0. Okay. And now suppose I have to maximize the moment, because suppose we have limited force. Suppose there is one. Okay, so let's take example. Now suppose this one is one nut and I have to open this nut. Okay, and for opening this nut, suppose I required 240 Newton meter of moment. Okay, to open this nut, this amount of moment we require. Okay, and we have the maximum capacity to apply the force is 5 Newton. Okay, so now suppose in this case, suppose I am applying force through this spanner. Okay, this one is a spanner whose arm or whose arm length is 10 meter. Okay, so when we apply force, this one is force. Okay, so moment will be what? Force into perpendicular distance. Force is how much? 5 Newton into perpendicular distance is this distance we have to take, because this one is its axis of rotation. Okay, so 10, so it will come 50 Newton meter. So as we have seen that this nut required 240 Newton meter of moment, but we are producing only 50 Newton meter of moment. So this nut we are unable to open. Now, as our capacity or our force is limited to 5 Newton, means we are able to apply only the force 5 Newton meter, 5 Newton. So what we have to do now, we are going to increase the moment. Okay, so moment can be increased by increasing the perpendicular distance. Okay, because moment is equal to F into D. So if we increase this distance D, moment is also going to increase. Okay, so here suppose this one is its axis of rotation, because nut is going to rotate about this point. Okay, and so length of or arm length of this spanner is suppose 50 meter. Instead of using this spanner, we are using second spanner. Okay, whose arm length is much more higher than the first one. Here also we are applying only same force 5 Newton meters. Now let's calculate how much moment we are going to produce. So moment is equal to force into perpendicular distance. Here force is 5 Newton and distance is 50 meter. So we will get 250 Newton meter of moment. Okay, so we are producing how much moment? 250 Newton meter of moment, and it required how much? 240 Newton meter. So now in this case, this nut is going to rotate, and we are able to rotate it. Okay, so have you observed that we have only this 5 Newton of force. Here also we have 5 Newton of force. Okay, but by increasing the length, perpendicular length, we have increased the moment. That's why whenever we are going to open a big nut, like heavy machines nut, okay, so have you observed that now the spanner or the wrench which we are using, that has more length. Okay, so whenever we have more length, we have to apply less force. So that one is the application of moment. Thank you.